All right, ready to dive into something we all know but maybe don't think that much about. Rain.
Sounds refreshing.
You're interested in cocktail party chemistry, episode 182, the chemistry of rain from sky to ground, right?
Right. It's got some pretty fascinating facts about rain.
Yeah, and we're going to uncover some cool stuff, like what's actually in rainwater besides H2O.
Definitely. There's more to it than just water.
Oh yeah, for sure. We'll also look at how those tiny little raindrops even form in the first place.
Like, how do they get so perfectly round? It's physics and chemistry all rolled into one.
And then there's the whole acid rain thing. Is it as scary as it sounds?
Well, we'll definitely break down the science behind it.
Cool. Then how rain messes with the air.
It's not just falling through it, it's interacting with it.
Totally. And even how it changes the ground beneath us.
Rain is a sculptor, shaping the landscape over time.
By the end of this deep dive, you'll be a total rain expert, like cocktail party level knowledge.
You'll be able to wow everyone with your rain trivia.
Okay, so when we think of rain, we usually think of just plain water, right?
Yeah, just pure, clean H2O. But it's actually way more complex than that.
All right, so spill the tea. What else is in this, secret rainwater cocktail?
So as raindrops form and fall, they kind of act like tiny little sponges. They dissolve gases from the atmosphere.
Oh, interesting. So it's not just water, it's like water plus air.
Yeah, and they also pick up these super tiny things called ions, which are basically electrically charged atoms.
Ions. Okay, where do those come from? Like the sky?
They come from all sorts of places, like dust, sea spray, and even pollution.
So each raindrop is unique, kind of like a snowflake.
Exactly. A raindrop falling in a city will have a totally different chemical makeup than one falling in a forest.
That's wild. And you know what's funny? One of our sources talked about how the FBA banned a certain red food dye back in the 70s just because it looked like a dangerous chemical. It wasn't even harmful.
Yeah, that's crazy. Appearances can be deceiving, especially in chemistry. You really got to look deeper.
So true. That actually reminds me of how raindrops form. It's not as straightforward as you might think.
Yeah, it's not like water just magically appears as raindrops in the clouds. It's a whole process.
So how do these little drops get so big?
It's a process called coalescence. Basically, tiny cloud droplets bump into each other and stick together.
So they're merging, becoming one big happy raindrop family.
Yeah, something like that. And as they combine, they get bigger and heavier until they're heavy enough to fall out of the cloud.
I'm picturing it like a mosh pit of tiny water droplets bumping and grinding until they form a giant mosh monster that's ready to crowd surf out of the cloud.
Haha, that's one way to visualize it. But besides all the bumping and grinding, temperature is important too. The water droplets have to be cold enough to stick together when they collide.
So it's like a dance. It takes two to tango, you know? Physics and chemistry need to work together to make rain happen.
Exactly. And speaking of chemistry, you had a question about acid rain, right?
Yeah, acid rain, it sounds pretty intense, like something out of a sci-fi movie. Is it actually as bad as it sounds?
Well, the name is pretty accurate. Acid rain happens when certain pollutants, especially sulfur dioxide and nitrogen oxides, react with water molecules in the atmosphere.
Okay, where do these pollutants come from? Are we talking like factories and stuff?
You got it. Mostly from burning fossil fuels. And these reactions create these acids, sulfuric acid and nitric acid.
So it really is acidic rain.
Yeah, but even normal rainwater is slightly acidic because of the carbon dioxide it dissolves from the air.
Interesting. So how acidic is too acidic? Like when does it become a problem?
That's a good question, and that's why scientists are constantly monitoring acid rain levels. Even a small increase in acidity can really mess with ecosystems, especially lakes and forests. One of the sources mentioned that it's kind of like how the FBA sets action levels for stuff in food.
Oh yeah, like those warnings on food labels.
Exactly. They're trying to find that balance between what's naturally occurring and what's actually dangerous.
It's all about finding that sweet spot. Like we want to enjoy our snacks without worrying about weird chemicals.
Exactly. And the good news is that regulations have actually helped reduce acid rain in a lot of places. It shows that when we understand the chemistry, we can make positive changes.
That is good news. So we've talked about acid rain, which is one way rain interacts with the air. But didn't you say earlier that rain also acts like a sponge for atmospheric gases?
Yeah, that's right. When those raindrops fall, they absorb all sorts of gases like carbon dioxide, oxygen, and nitrogen. And that dissolved CO2 actually makes even pure rainwater a little bit acidic, but not as acidic as acid rain.
Okay, so there's a natural level of acidity, and then there's the acid rain level.
Exactly. And get this, the levels of these gases in rainwater can actually change depending on different things.
Like what? Like the weather?
It can be the time of day, even the season.
Wait, really? Like rain falling in the morning might have a different stuff in it than rain falling at night.
You got it. It's kind of like how our bodies have these internal clocks that affect how we process things, like how our livers work.
Wow, everything is connected. So we've got this whole chemical party happening in every raindrop, and it's affected by pollution, time of day, all kinds of stuff. What happens when all these chemically charged rain finally hits the ground?
Well, that's where rain really gets to show off its artistic side. It starts sculpting the world around us. Yeah, rain doesn't just water plants and fill up rivers and lakes. It actually like shapes the ground beneath our feet.
Yeah, that makes sense when you think about it, right? Like we've been talking about all the stuff rain pick up from the air.
Uh-huh.
So what happens when it like hits rocks and dirt?
Well, you know how even pure rainwater is a little bit acidic?
Right, right.
That acidity actually lets it slowly dissolve rocks over time.
So it's like a slow motion sculptor
Exactly.
carving canyons and mountains over like millions of years.
It takes time, but it's powerful. And it's not just the big landscape stuff, it also changes the soil itself.
Oh, really? How so?
So when rain soaks into the ground, it dissolves minerals from the rocks,
Uh-huh.
and those minerals get carried deeper into the soil, which is like super important for plants.
So rain is like delivering a nutrient package deal.
Pretty much, it breaks down rocks and gives those essential minerals to the plants.
It's not just watering them, it's feeding them too.
Exactly. And you know how the gas levels in rainwater change depending on the time of day?
Yeah.
Well, the time of year can really affect how plants absorb those minerals, too. It's all connected.
We keep talking about how rain shapes mountains and stuff, but I wonder what it does to buildings.
Yeah, good point.
If it can dissolve rocks over time, what about concrete and steel? Like, what's it doing to our cities?
You know, that's a question scientists are actually studying right now.
Wow, really?
It turns out rain can definitely wear down building materials, especially if they're exposed for a long time.
So even our cities are being shaped by rain.
Yeah, in a way, it's kind of like that FDA story with the red food dye. It's a good reminder that looks can be deceiving.
For sure. Even everyday things like rain have hidden depths.
Absolutely. And scientists are always trying to come up with new materials and building techniques that can handle the effects of weathering better. It's like a constant back and forth between science and engineering.
Speaking of science, one thing that really stuck with me from the sources is the idea that rain can pick up microorganisms from the air.
Oh, yeah, like bacteria and fungi.
So not just chemicals, but tiny life forms
It's
too.
like rain is this giant taxi service for microbes, carrying them all over the place.
A microbial taxi service, that's wild. So rain brings down chemicals, shapes the land, and spreads tiny organisms.
Yeah, it's doing a lot.
What does that mean, like, for the environment?
Well, scientists are still figuring all of that out, but it seems like these rain-borne microbes can do all sorts of things.
Like what?
They can spread plant diseases, but they can also help plants grow by giving them nutrients or protecting them from bad stuff.
So it's not all bad?
Nope, it's all about balance. Some microbes are helpful, some are harmful. It just depends.
Rain is so complex. It's incredible to think that all this is happening in every little raindrop. We've talked about what's in rain, how it forms, how it affects the environment. But I'm curious, how do scientists actually study rain? Like, what tools do they use?
One really cool technique is called isotopic analysis.
Isotopic analysis.
Yeah, basically they look at these things called isotopes.
To be honest, my chemistry is a little rusty. What are isotopes again?
Oh, it's simple. They're just atoms of the same element, but with a different number of neutrons.
Neutrons, right.
So like the most common type of oxygen has 8 neutrons, but there are other types with 9 or 10.
Okay, I kind of remember that from school. So how do isotopes help scientists understand rain?
Well, the ratios of different isotopes in rainwater can tell us a lot about where that water came from and what happened to it in the atmosphere.
Like a detective story.
Exactly. They can figure out things like where storm formed, how air currents move, even past climate patterns.
So these tiny little isotopes in rain are like time travelers, holding clues about Earth's history.
It's pretty amazing, and that's just one example of the incredible tools scientists use to study rain chemistry.
So we've talked about what's in rain, how it forms, how it affects the land, how it carries microbes, and even how scientists are using isotopes to uncover its secrets. Is there anything else about rain chemistry that blows your mind? Like, what are researchers still trying to figure out?
One really interesting area is the role of rain in cleaning the atmosphere. You know how we talked about rain-absorbing gases?
Yeah.
Well, it actually helps remove pollutants from the air, too.
So rain is like nature's air purifier.
Exactly, like those sulfur dioxide and nitrogen oxides we talked about. When they dissolve in rain, they can be transformed into less harmful compounds and then fall back to Earth.
It's like a giant filter in the sky.
That's a great way to put it. But you know how that FDA thing with the food dye showed us we need to be careful?
Yeah?
Well, even this natural cleaning process can have some unintended consequences.
Oh, really? Like what?
Well, sometimes, even though the pollutants are less harmful, they can still cause problems when they end up in lakes and streams. It can make the water too acidic, which is bad for the plants and animals that live there.
So it's a trade-off.
Yeah, it's a balance. Like rain cleans the air, but we need to understand how that cleaning can also affect the environment.
It just shows how interconnected everything is.
Exactly. And that's why scientists are constantly studying this stuff. They want to understand all the complex interactions between rain and the planet.
This deep dive has been so cool. It's amazing how much we just don't think about with rain.
Yeah, right.
Like we learned about all the chemicals in it, how the drops form the acid rain thing, and how rain messes with the air and the ground.
And even living organisms. Remember those little microbial hitchhikers?
Oh yeah, it's like a whole world happening in each tiny drop.
And we only scratched the surface. There's so much more to uncover.
You know, one thing that really got me thinking was the timing of rainfall. You mentioned how our livers work differently at night.
Yeah, our bodies have their own schedules.
And you said the stuff in rain can change depending on the time of day, too.
Right, like those dissolved gases.
So I was wondering, are there other examples where the timing of rain matters?
Actually, there are tons. One cool example is how plants absorb nutrients.
Oh, interesting.
Research shows that plants are better at taking in certain nutrients at different times of day.
So like a morning rain might help plants grow differently than an evening rain.
Exactly. It's not just the amount of rain, it's also when it falls.
Nature's got a timetable.
And just like those FDA action levels for food keep us safe, understanding nature's schedule can help us protect the environment.
We've covered so much in this deep dive. We talked about the chemicals in rain, how the drops form acid rain, how rain interacts with everything.
From the air to the ground to tiny organisms.
Before we wrap up, what's the one big thing you hope our listeners take away from all this?
I think the biggest takeaway is that rain is way more than just water falling from the sky.
Yeah.
It's this super complex system that literally shapes our planet and impacts all life.
It's a reminder that chemistry is happening everywhere, even in a simple raindrop.
And the more we learn about it, the better we can appreciate our world and make good choices about how we treat it.
So next time you're out in the rain, remember all the amazing stuff happening in each little drop.
It's like a science experiment unfolding right before your eyes.
Thanks for joining us on this deep dive into rain chemistry, inspired by cocktail party chemistry. It's been a wild ride.
I hope you had fun exploring the hidden world of rain with us.
And hey, maybe you'll even have some new rain facts to impress your friends at your next cocktail party.